Okay, an amusement park ride consists of a large cylinder that rotates around a vertical axis. So this is the vertical axis, and this is the cylinder rotating around. When the rotational speed is high enough, the ledge drops away, and people stick to the wall. So the ledge will drop away, and this guy will be stuck to the wall. So this ride will be moving around so fast that this guy is not able to move. He is literally stuck to the wall. He can't go up, he can't go down, and he can't go this way. So the period of rotation is 2.5 seconds, and the radius is 2.5 meters. So this is 2.5 meters, and it takes 2.5 seconds for one cycle to complete. So what is the minimum coefficient of friction required to keep the riders from sliding down? Okay, so we have an expression for the coefficient of friction. So mu, that is equal to the force of friction all over Fn, the normal force. So where are we going to find these two forces? Well, let's redefine centripetal force again. So what is centripetal force? It is the center-seeking force, the force that seeks the center. So say this is the center. What is the force that is seeking the center? Maybe you've seen it, maybe you didn't. It is the normal force, right? The normal force is always perpendicular to the surface. So the normal force is what is going towards the center, or what is seeking the center. Okay, so now that we have the normal force, we define that as the centripetal force, we need to find our force of friction. So we know that the force of friction is always in the opposite direction of motion. So let's look at the vertical motion of this guy. Vertically, there's no motion. So what are the forces acting on this guy vertically? Well, we have a force of gravity, Fg. However, if it was just the force of gravity, this guy would be falling down towards the bottom. So there needs to be another force that's keeping this guy from falling. And that force has to be equal to this, right? When these two forces are equal, there's no motion, abiding Newton's first law. So that force is the frictional force. Same in magnitude, opposite in direction. This frictional force is keeping the guy from sliding down. It is in the opposite direction of motion, right? The motion is this way because gravity is pulling you down. So the friction is opposing this motion, thus keeping the guy stuck to the wall. So now we just solve for friction and Fn and plug it into this. So let's solve for friction force first. So the sum of the forces in the y direction, that equals 0, right? No motion. So the force of friction minus mg equals 0. Fg, mg, and Fg is going to be negative, right? So that's why we subtract it from the positive friction. Therefore, the force of friction equals mg. Okay, now let's find an expression for the normal force. So the normal force we defined as the centripetal force. And we have a formula for the centripetal force, right? So that is equal to mv squared over r. And we can say the normal force is equal to mv squared over r. However, we come across a problem. We don't have v, and there's no way to find v. However, we do have an expanded version of this centripetal force, that being the one that includes the period, and we have the period, that is 2.5 seconds, so we can use that version of the centripetal force. So Fn equals m4 pi squared r all over t squared. This is the expanded version for the centripetal force. So now we can just plug them back into our mu expression. So mu, the coefficient of friction, equals mg over m4 pi squared r all over t squared. We can say we can multiply this by the reciprocal, so we can say mu is equal to mg times t squared over m4 pi squared r. And you notice we come across a problem, right? We don't have the mass. So how are we going to solve for this? Well, we can just cancel out these masses, right? abiding the conservation of energy laws. So now we're left with a simplified equation saying mu is equal to g times t squared all over 4 pi squared r. So we know g, right? We know 4, we know pi, and we know r is 2.5 meters, and the period. So what is the period? Well, that's 2.5 seconds per cycle. So we can just plug in all our values. So mu is equal to 9.8 times the period squared, so the period being 2.5 seconds, all over 4 pi squared times the radius, so 2.5 meters. You plug that into your calculators and you end up with a coefficient of friction being 0.62.